Hello, everyone. Welcome back to GenFarmer's no-code automation course. Today, we will explore a new feature, creating web captions on Instagram using AI.
Today, we will explore a new feature, creating web captions on Instagram using AI. Before automating, we'll create a workflow to manage the processes. I have a map ready here. Let's unify today's flow. First, we'll select a topic. After choosing the topic, we select the photos to be published. Next, we'll use AI to generate descriptions based on the selected topics. Then we publish. For topics, we can't have multiple accounts posting the same thing, right? That's why we'll use a variable. We'll input several topics, and the system will choose one automatically. The same goes for images. They'll be chosen randomly from a gallery. We can't post the same photo on all accounts. Now, for generating descriptions with AI, first, we choose the AI to use. We can use Gemini, GPT, or other similar tools. The crucial part of generating descriptions is the prompt. You can create your own prompts as long as they meet your goal. I prepared a simple sample prompt for your reference. We assign the AI the role of an expert Instagram copywriter. Its task will be to create descriptions based on the topic variable we input. Additionally, we must add mandatory rules for the AI to follow. If this is your first time using the Gemini API, remember this. The Gemini API is like the web version, but without memory. Each request is a new and independent interaction. That's why we need to establish clear rules and context. First, generate only plain text and return a single description. Second, it's forbidden to provide explanations or analysis in the response. Avoid responses like, "Sure, here is your description for this topic." If we post that, the platform will detect it as AI-generated content. They'll know it's not a real user because of those unnecessary explanations. That's why strict restrictions are mandatory. Third, the caption should not be in quotation marks. We set this rule to prevent the AI from following rigid formats. AI tend to wrap responses in quotes, which we must avoid. Finally, we limit the text length. We force it to be a single block of text, 1 to 2 sentences, to avoid long descriptions. This is a demo prompt. You can customize it according to your needs. Besides a posting flow, today we'll develop a very useful feature. It works for automating any social network, even X or Facebook. It's about interacting with existing posts in the feed. The logic is similar to posting content. First, we extract the content we want to interact with. Then, we send that data to our AI. The AI analyzes the content and generates a relevant comment automatically. The hardest part of this flow is correctly extracting the post content. The AI processing is identical to the previous one. The key to success lies in how we structure prompt. I've created a sample prompt here. First, we assign the AI the role of a real Instagram user who comments naturally. Its task is to create a short comment based on the post content we'll insert. In the workflow, we'll take the post text and place it here as a variable. Just like before, we establish strict rules for the AI. It should only generate the final comment, without explanations, analysis, or bullet points. The comment must be directly related to the context of the post. The AI will analyze the topic and generate a response between 4 and 12 words. We avoid long text. It should sound natural and friendly. We must avoid a spammy tone. No generic comments. We forbid empty phrases like "great post" or single words like "cool." If the post content isn't clear, the AI won't be able to analyze the context. For those exceptional cases, we'll set up default responses. That was a summary of today's flow. Now, let's start processing the task. We return to the GTool interface. We'll reuse the previous login flow. First, we verify the application. We check if Instagram is already installed. If it's installed, we open it. If not, we start the installation. Once open, we verify if the interface is ready to post using the inspector. We create a status check. If it's not ready, it waits. This prevents errors on slow devices during automation. When the app is active, we activate the application. We look for the Create Post button and copy its XPath. Here we'll create a loop to verify the appearance of that button. If the button is not detected, the system will continue in the loop. We configure the loop to repeat a maximum of 10 times. If it doesn't find the button after 10 attempts, it will print an error notification. We use a throw node to record the failure in the log. When we see the error, we check the device to debug and solve the problem. If it detects the publish button correctly, we exit the loop using stop/break. Once the loop is stopped, we execute the main action. Click on the button. We run the flow and use the element key to perform a click. If the click is successful, it means the workflow is functioning normally. Now we save and return to our mind map. The first step on the map is to select the topics for the automatic post. To randomize the topics, we first need to create a variable. This will be a list variable type. It will contain all the topics we want to rotate randomly. The topics within the list will be separated by a specific delimiter. Topic 1. We set up a good morning message, wishing for a positive day. Topic 2. A caption about relaxing night, a chill evening. With the topic list ready, we'll use a JavaScript node to select one at random. In the code, we use the getVariable function to call the data from GenFarmer. We get the value of the tappy variable we created earlier. We assign this value to a constant within the script. We use the split\n function to separate the topics by each line break. Once the array is created, we use math.random to select a random index. We use setVariable to save the selected topic in the GenFarmer tappy variable. We run the test. Result, good morning. The logic works correctly. Next step, uploading images. We configure the click on the Create Post button. Upon execution, the system takes us to the device gallery. I have 4 images ready. How do we select one at random? Back to the inspector. We need to capture the image elements. We'll look for a common XPath to automate the random selection. First, we select the photos available in the gallery. We analyze common attributes of these images to optimize the workflow. Notice the structure. The first photo is in view group 2. The following ones are in 3, 4, and 5. They share a parent element and are distinguished by their index. We'll use this structure to create the XPath. Standard XPaths are often unstable. That's why we'll use an advanced XPath. Let's inspect the element hierarchy here. By tracking the elements, we see that photos 2 and 3 are here. The common point is that they're all within a grid container. This parent container is static and more stable than the other elements. We'll use this container as a starting point to filter the child elements. We copy the parent container's attributes to ensure XPath precision. With this attribute, we capture the exact group of images. Now we query the child elements. Be careful. The first element is a camera button, not a photo. If we click there, it will open the camera. We must exclude it. The difference is that actual photos have a specific image attribute that the camera button lacks. We'll use a class name to filter and select only the images. We configure the query to target photos 2, 3, and 4, ignoring the camera. Once filtered, we can use a random function. The system will randomly select one of the valid photos from the list. We create a random numeric variable, random number, from 1 to 3. This variable will define which photo we select at random. After creating the variable, we configure the click on the image based on the generated number. Before clicking, we add a short delay, sleep, to stabilize the flow. We run the test. The system will choose one of the 4 photos. In this case, it selected photo number 2 and clicked correctly. Once the photo is selected, we click Next. We copy the button's XPath and configure the click action. Options for editing and music appear. Text options appear, but we don't need them. Click Next again. An OK pop-up appears. Let's go back to the inspector. Reload the inspector to capture the OK button and configure the click action. Important note, this pop-up does not always appear. Therefore, we connect the fail path to the next step, like this. If the button doesn't exist, the flow continues without crashing. Crash avoided. Reload the inspector again to get the next XPath. We connect both nodes to ensure the continuity of the flow. Now we will configure the artificial intelligence nodes. We will use 3 models, Gemini, ChatGPT, and DeepSeek. Drag the DeepSeek ChatGPT, and Gemini nodes into the workspace. We'll create a configuration option for the end user. This allows them to choose which AI API to use, Gemini, ChatGPT, or DeepSeek. Create a variable named AI_model. It will be a selection type variable to customize the desired model. Assign values. Gemini as option 1, ChatGPT as option 2, and DeepSeek as option 3. Additionally, create a system API variable for the user to enter their API key. Configure the node. Starting with Gemini, enter the API key and select the model. Copy the prompt we prepared earlier. Paste the prompt. Now insert the topic variable. If you forgot to create the topic variable, create it now to capture the random theme. When it reaches this node, the AI will know to write about topic 5. For example, the generated result will be saved in a new variable called caption. Repeat the process for the other nodes, copying the prompt to save time. Connect all AI nodes to the same output point to unify the flow. Once we have the caption, the next step is to type it into the post. Configure the API keys. In this example, I'll use DeepSeek. The process for Gemini and OpenAI is identical. Assign the output variable. Configure the type action with normal speed. The content to be written will be our caption variable. To test, move the execution point here to simulate the process. This avoids running the entire flow from the first step, which will be slow. Running, it errored because I forgot to select the AI model. Corrected, I select model 3, DeepSeek. Let's run it again. Now the flow processes correctly with DeepSeek. Let's see the result. The AI has generated the text. Caption. It randomly selected the good morning topic and wishes everyone a great day. The content is very good. It spreads positivity and automatically includes 2 hashtags. Running again to choose another random topic. This time it selected the evening/night topic. It generated a very appropriate option about relaxation and nightly rest. Once we have the text, we proceed to publish it. Click OK. Use Inspector to capture the XPath of this button. Here we configure the OK click. Important. Add a 5-second delay after typing the text. Then we click the final button, Share. With this, the post has been successfully uploaded to Instagram. Add an extra step to close the post window or notification. Now we move to the second workflow, News Feed Interaction. Returning to our mind map. First, we must extract the content of the post we want to interact with. Navigate to any post. For example, we'll take the text from this caption. This is the content we need to extract. Back to the inspector and click Reload to update the interface. Just as we did with the images, we capture the text element. We must capture it intelligently so it works with any post. Select the element containing the text and analyze it. The text attribute contains the current content. We cannot use this attribute for the XPath because the text changes in every post. If we use a rigid XPath based on the text, it will fail on other posts. If we switch posts, the previous XPath will fail because the text changes. That's why we must find a static XPath. We notice the class name is of type TextView. We verify if this XPath is unique on the screen. If it's unique, we can use it directly to extract the content. If there were duplicates, e.g. a count of 2 or more, we would look for other distinctive attributes. Fortunately, the XPath here is unique. We'll use it. We use a getAttribute node pointing to this XPath. The desired attribute is text. This way we'll get the caption content and save it into a variable. Let's try another post to verify if it works. Let's try to extract this caption. Notice, this text is longer than the previous one. The text is truncated by the More button. We need an extra step. We must click More to expand the text before extracting it. We locate the More button within the structure and configure the click. This ensures we capture the exact button. We execute the click first. We add a small delay and then extract the value. By expanding it, we get the full text. Now we'll send it to the AI. But first, we need to configure the scroll and like interaction flow. We'll reuse the previous node, random scroll and like. We copy the flow. After the like, we'll add the option to comment. Drag this block down to organize the flow. After publishing, we execute the loop for random interactions on 1 to 5 posts. We establish the logic. If we like, then we proceed to comment. We will only comment on the post we have marked with a like. If we don't like it, we ignore the post. It will be strange to comment without interacting first. It's natural to like and not comment, but not the other way around. Therefore, in this flow, the comment is only triggered after the action. To comment, we need to extract the previous post content. The more button only appears for long texts. Sometimes it won't be present. To avoid errors, we connect a fail path to the next step. We reduce the wait time to 2 seconds. Once the text is obtained, the AI analyzes it. We'll use the same 3 AI models as before. I'll copy the existing nodes to save time. On configuration, here we must make an important adjustment. Change the prompt. We'll use the comment prompt we prepared earlier. We copy it, paste a new prompt, and replace the input variable with getCaption. It's the variable with the text we just extracted. With this, we have a complete prompt to interact automatically in the feed. What follows after generating the comment? Click on the comment icon. We use the inspector to capture the XPath of the comment button. We configure the touch action on that element to open the dialog box. Next, we configure the type action. But first, let's analyze the XPath. The current XPath is too long. It's an absolute XPath. We must find a better one. By clicking here, we get a much shorter and more stable XPath. Long XPaths usually contain numbers or indexes, making them dynamic. If the app updates or we switch devices, those indexes change and the flow will fail. Always analyze the XPath. Avoid dynamic ones to ensure a smooth flow. Here, the child element gives us an excellent and robust XPath. We'll use it. We configure the click on this XPath. Then, we use the type text action to enter the value directly. We'll use the comment variable as output to maintain the correct context. We use DeepSeek. We configure the comment with the extracted value. I forgot an important step. Clicking the More button. Since we had already expanded it manually, it's now hidden. If we run it now, it will fail. We correct it so it gets the content properly. Once the post text is extracted, the AI analyzes it and generates a comment. The extracted content is about a love story and an anniversary. The AI has generated an excellent comment, congratulating the couple on their anniversary and wishing them 100 more years of love. It's very contextual and precise. If we did it manually, we'd waste time thinking about what to write. Here, the AI does it fast and accurately, but there was a technical error. The AI generated the text, but the system failed to type it. The error indicates it couldn't click the XPath element of the text box. The XPath we used before depended on the hint text, but that text changed, breaking the XPath. We must fix it. We look for a stable XPath that doesn't depend on the visible text. We'll focus on the resource ID. We see that the ID is Gemini editable. This is much safer. We'll try capturing this resource ID attribute. We remove the extra white spaces and configure the new XPath. Now we test this new XPath on the interface where it failed earlier. Does it work? The new XPath detects the element correctly despite the text change. It's a robust XPath. We integrate it into the workflow. We increase the wait time sleep slightly to ensure the interface loads. We set a 2-second wait before it starts writing the comment. We run the flow again from the More button step. Since the More button was already pressed and disappeared, the system detects the error and moves forward. It proceeds to extract the content and send it to the AI. The AI generates a new and unique comment. Each interaction is different and contextualized to the post topic. We return to the final node. Once the comment is written, we publish it. Comment sent. Now we must go back to continue the flow. We use the back button. We need to press it twice to return to the feed. We create 2 press back nodes and navigate correctly. This way, the flow continues and looks for the next post. Let's test the execution. I'll set the probability to 100%. We'll limit the test to interacting with only 1 or 2 posts. With 100% probability, it will interact with every post it finds. The flow likes, extracts content, comments, and repeats the process. If it doesn't like, it will skip the comment. We connect that case to the start of the loop. This ensures the loop continues. At the end, we close the application. Next step, optimizing the mind map and configuration interface. We'll make it easier for the end user to use. We reset the configuration. We select the Vietnamese language. We remove the old nodes to start from scratch. We add a button for the user to choose whether they want to interact. We create 2 options, on activated and OFF deactivated. We adjust the button width and set it to on by default. Then, we add a selector to configure the interaction percentage. We configure the like rate. Options, 33% or 100%. Default, 33%. We name the variable rate_like. Field width, 250. The user can choose the probability of liking. We add a field for the AI's API key. Variable, IAPI. We create a selector for the AI model. We define 3 options. 1, Gemini. 2, ChatGPT. 3, DeepSeek. We assign the variable AI_model. Now we configure the topics. We use a text area for multiple lines. Variable, list_topic. The user will enter their list of topics here. The system will choose a random topic to send to Gemini, GPT, or DeepSeek. We separate the functions. We don't always want to publish and interact at the same time. We add control buttons on to activate each function independently. We create the on variable for the post function. We do the same for interact. The commenting function will depend on interaction. We update the mini app with these new control options. All that's left is to add the publish option. For these buttons to work, we must connect the variables to the workflow. Here we configure the logic. We add a condition node, business logic. If the post option is on, it will select the topic. If it's OFF, it will skip posting and go directly to interacting. Ready? Now we're going to export this script to upload it to the store. We go to the menu, select export, and choose the open source option. This way, the code is visible for anyone to study and customize. They can log in and post on Instagram for free with their own modifications. We click Export App and save the file. Now we go to the GenFarmer web store. To upload apps, you need to register as a seller. It's quick and simple. Once approved, let's go to Apps-New App. We name the application Demo Instagram and upload the script file. In the release notes, write the changes, e.g. version 1.0. Compatible devices, leave as default. Visible name, Demo Instagram. Upload an icon. I'll use the Instagram logo. Category, Instagram. Price, you can sell it or set a rental. I'll set it to free. If you were charging, you configure the price and trial here. Language, Vietnamese or others. Title and description, detail the function. Instructions, explain how to configure and use the script. After completing everything, click Request Review. The GenFarmer team will verify the script for malware. If it's safe, they'll approve it. Click Update. Success. Now we wait for approval. With this, we conclude today's course. We learned about GenFarmer nodes and Instagram automation. We saw advanced techniques using Gemini and GPT to create content and interact. You can expand this knowledge to create auto-reply or messaging bots. I hope this course helps you create your own tools for your work. Much success to everyone.